Problem 13.110 involves a space vehicle in a circular orbit at 225 miles altitude above the Earth. It wants to return to Earth by decreasing its speed here at A by firing the rockets in the opposite direction of the travel. That will slow it down then and put it into an elliptical path that ends up at point B at 40 miles altitude at an angle of 60 degrees. It wants us to find the velocity at A after the rockets have been fired. So it's the velocity for the elliptical orbit, and then find the velocity at B. All right, we're going to do this by using the conservation of energy. R sub A is the radius of the Earth plus the altitude of 225 miles to give us 4185 miles. Radius of the Earth is 3960, as mentioned here in the picture. V sub B is 60 degrees, as said in the problem, and R sub B is radius of the Earth plus 40 miles, which gives us 4,000 miles for R sub B. So we want to find V sub A after the rockets are fired, then, and you're in an elliptical path where energy is conserved. So you write out T1 plus V1 equal T2 plus V2, and you get 1/2 MVA squared right here for kinetic energy. The potential energy at that time is minus GMM over R sub A. The kinetic energy later is 1/2 MVB squared, and the potential energy is a minus GMM over R sub B. Remember too that we can substitute GM equal to G, little g times the radius of the Earth squared. Angular momentum is also conserved in this path that allows us to write RA, VA. Technically it's RA crossed into MVA, but the M's are going to cancel out both sides here. And so you're left with RA, VA sine of theta A, but theta A is 90 degrees, and sine of 90 degrees is 1. And then you're going to have RB, VB sine of phi B left here, and we have numbers for those. So we can solve for B in terms of A, V sub B in terms of V sub A, and plug that into equation 1 right here, and rearrange terms around a little bit, and you get this right here, in which you can solve for VA and get 11.32 times 10 to the 3rd feet per second. Once you've got that value, you can go back up here in equation 2, plug it in right there, and get a V sub B then. That's 13.68 times 10 to the 3rd feet per second.